Hi guys, welcome to Learning Electronics Repair. I had this here a while ago. This is a power supply board out of an audio mixer. And we had a look at the repair of this area. So this was all burnt up. I've basically looked at that, removed the various burnt components, worked out what the circuit was, and I linked the other video, it was a while ago. I then made a follow-up where we were testing this op-amp chip and we found it to be faulty, so I ordered some spares. They've been here a little while and I'm now going to complete the job. What basically happened with this one, if you didn't see the previous video, is that this area is all burnt, you can see. And basically there's a circuit track that passes through this area but doesn't connect. This area is part of the fan control, cooling fans, and this all runs on plus and minus 15 volt supply. And I wonder, well, how can this get burnt? I mean, these are high value resistors, there isn't any real amount of current in this area. How can it get burnt? And it turned out that there's another circuit trace, the one that passes through, which has the minus 95 volt rail. And the trace goes this way. You can see I lifted a lot of these components on the previous video so we could follow where the track is. It's actually that one. Here, you can see it has like this corrosion noise. It goes to this connector, in actual fact. I actually removed this socket so we could see where it went. And this track is not really water damage that's caused this. It's just some sort of airborne thing we get here, whether it's the humidity down by the ocean, the salt water. It seems to be that high voltage tracks kind of attract this corrosion. If we follow the track, it actually comes up this way. This is it. So it goes to this resistor, it goes under here, under there, and then this is where it arced over, I think. So when it arced over, basically it destroyed the two chips. We've got chips now. It burns some resistors, probably just from the PCB burning. And we now need to fix the damage. So what I'm going to do with this, I'm not going to send the 95 volts down this corroded looking track anymore. I'm actually going to cut the track here. I'm going to cut the track at the other end here, or probably actually just outside from that connector somewhere here. And then I'm going to solder a piece of wire from there to there. After that, we won't have the 95 volts traveling down here anymore. I'm fitting the two replacement chips, and then I'm going to replace the burnt resistors, and there's a capacitor there as well. But I'm not going to replace the components in the original holes because this is all kind of charred. I'm actually going to replace them effectively by connecting to the pins on these chips where the resistors actually go to. Therefore, I kind of like isolate this area. I won't be using it. The components will just be mounted further across the same components. So let's do it. I think the first thing, I've actually inserted a chip here, but I'm not going to solder it just yet. I'm going to take it back out. I'm going to replace this 95 volt wire, and then we'll do the chips and then we'll look at the other components. First of all then, I'm going to cut this track here. In the previous video, if you have a look, I actually traced this track all the way through. That's why there are so many components lifted up. So I do know this track doesn't go to anywhere else. There's no wires, there's no branches off going anywhere else. So we can cut this here. And you can see I've actually managed to cut the track, and then I've just realised in actual fact that this connector goes all the way to here. So I just need to actually repair that with a little bit of wire. I'm going to put a little bit of epoxy adhesive on to cover it over, and then I'm going to fit this socket back on. I'm actually going to come into the track somewhere here. So we'll just fix that little mistake. Yep, bit of solder on there so it's nicely tinned. Yeah. And in fact, I'll actually go a little bit more this way on this one. there. I've actually switched over to using the optical microscope for this because when I'm doing fine work like this, I really need the stereo vision. I struggle to do this with a USB microscope. That wire is actually too thick. Let me find something a bit thinner. And I think I have it. We can soon check. We'll just take the end bit off. In fact, that actually seems to be all the way down that track. It's just followed it. So we'll take this end off. I'll add a touch more solder to this end. This is probably where I'll mess it up. But no, looks like I got away with that. Let's check this for continuity. So from the connector, and it comes down this track. Yeah, and we have good continuity there. That's solidly attached. Yeah, I'm happy with that. Let's clean that up. Yeah, that looks good enough for me, guys. So I can solder the socket back on. First I will just actually attach the wire from here, and this is going to go to the other end where the power resistors are. You can see, guys, this track is really nasty, but this is not water damage. All the other tracks near to it are basically okay. I mean, you know, water's like a blob. It's not something you get across a whole length of track like this. I can only say it's something to do with the proximity to the sea, the salt air here. I don't recall particularly seeing this sort of damage when I was in the UK, so maybe it's just something unique to the Canary Islands or similar places. Okay, that's rust basically. Right, let's dry that off, and then let's have a look if we can solder that wire. I'll add some fresh flux to the track. I'm going to tin this track first, and then we'll tin the wire and see if we can get it to solder how we want it. Let's see. So the wire is going to come in here. It's not too thick. I'm actually going to rotate this board so I can solder this right-handed. That's the way I normally work. So for me, it's easier to spin this board around. I've just bent the wire slightly. So I get it to go flat, and see if we get it to go onto here. I'm hitting something with a soldering iron as a power device or a heatsink. Well, I think I've actually got it to, yeah, I've got it to join onto there. So that cooled down a moment. That looks good to me. Again, I will just clean this up, make sure we have a sufficient gap here. I can actually get under there, so I think we do have. And I'm going to put some epoxy resin on this anyway, partially to help to insulate and partially to stop the wire breaking away from the board there. If you guys have not worked with an optical binocular microscope before, try it if you ever get a chance. But if you do try it, you will not go back to using the USB one. I can tell you that for now. I owned a USB microscope. It was one of the Andon store. Before I had this optical one, once I bought the optical one, I didn't use it, so I sold it. I've since reviewed another Andon store, which actually I thought was a little bit better, and that's the one I now have mounted over the workbench actually for video, but when it comes to actually doing this work, this is far easier. Okay, so that looks pretty good. Just before I put the epoxy resin on, I just want to check this track next to it. I think it's okay. I just want to check it where it goes under the silk screening. So we're going to come from this track. Yeah, we have continuity. Okay, so that's fine. This is quick set epoxy resin. And I'm literally just going to put some on there. And that should keep the wire in place and basically act as a better insulator. That's the theory. This stuff does seem to insulate rather well. Okay. So now just let that dry. Okay, that is fairly hard now. It's still setting a little bit, but it's getting there, a little bit tacky. So I'll just let that finish off, and then I will test the continuity from the end of the wire to here. If all is okay, I will then fit all these components that I lifted. So I lifted all these so I could follow where the track was going. You can see where I was, where I've lifted some more components, and then it heads this way so you can see more. So I've been all the way across this board. I've also removed a couple of capacitors down by the burnt area, but I'm actually going to take the wire the other side. So I'm going to bring the wire the other side of these components, yeah, over to this side, up here, up in this area, and then you'll see just the side of this connector is the power resistor. So I'm going to route the wire around that way. Actually, in fact, I may even go around the back of here because there's a nice gap to feed it in. I've resoldered this socket. You can see where I've actually fixed the wire under here. This goes to the end of this resistor, and it goes to pin 1 in here. So we can actually just check that to make sure we have continuity, and then we can repair the remainder of the damage. I have the meter on diode test actually, but it will do for continuity, so we can get onto the end of this resistor, and we should have continuity to this pin. Okay, so that's good. Now we have this damage in this part of the board. We have the two ICs to fit. This one I have inserted but not soldered yet. I'm just going to fit them both. And I worked out on part 1 what was actually happening here because I have a schematic, but a subscriber also sent me some photos of a good one, so that will help. Let's solder these chips in first because I may end up soldering the resistors direct to the chip legs rather than trying to solder them into this area. You can see there's a track here which is a bad track that passes underneath this IC. This is actually the minus 95 volt track that's arced over, goes off up that way, but I actually replaced that with this piece of wire so we don't need to worry about that. We can quite simply solder our ICs in place. I did consider fitting IC sockets here, but considering this thing is used portable and they get thrown around a little bit, I decided it's probably better just to solder new parts in. Let's look at the schematic now. So in part 1, I actually worked out that the missing parts were R18 and R19 and R16, which is in this area. There, that one. So those are the 3 resistors that's actually burnt up. We can see that these 2 effectively join together and they go to the op amp, and they also go to this point A, which is in this circuit here, A. So that's connected to there. Now you can see that the junction of the 2 resistors also goes to R20. So if that is nearby, I can actually attach the resistors to that point. They then go to 17 volts, which we can see is also on one end of R10. So I can easily attach R18 effectively from R10 to R20 if they're close by. And this one goes to 0 volts, which we can see is also here on R14 on one of these capacitors C19. So we should be able to find those points quite easily and effectively connect these resistors where they should go. R16, I think again, yes, one end goes to 17 volts, the other end goes to R17. So hopefully again we can strap that resistor between the two and we can just check the continuity to these chips to make sure it's okay. Having worked all this out on the first video, I was then actually sent some photographs by a subscriber. So this is Andrew Eastman. Thank you, Andrew, very much for this. He sent me these photos of a good board, so we can have a look. Here we can see the photograph and we can compare it with our board. So we can see where the resistors should go. Here are 18, 19 and 16. These resistors are okay on our board and these resistors are okay. So I'm fairly confident we can find somewhere to attach these. Let's have a look at the other side of the board. Here we can see where the tracks go. So if you look at the damaged one, you will see that we have effectively a track there that's missing. This is the ends of two of the resistors, but we can tag them to here. As this part is just completely missing, we can keep away from the charred area. This track is missing altogether. We can put that back in. That shouldn't be a problem. But from this end, actually, this goes to one end of our resistor again. So I will put this track in because I think this may go to somewhere else on the other side. We can put a wire across from here to here, and then we can actually attach our resistor. But we can actually put the resistor from here to here if we wish. Then we have this one, which goes to this resistor next to it. So that isn't too difficult to put all that back together. Let's do it. So the first resistor we can fit back on is this one. Now you can see there are two tracks coming under here. This was the minus 95 volts that went up that way. This is the one that's arced over, but we've now bypassed it, so we don't need to worry at all. And there's one that goes from this capacitor through here to somewhere under this chip. But we can figure out where that one's going. We can see it goes from here to here. So I can actually cut this off here and cut this off here somewhere and solder a short wire there. I think to make this easier, I'll actually do that before I fit the resistors. This end of the track clearly goes to the chip, pin 3. So if I tag a piece of wire on here, I only need a thin piece of wire. This is an input on an op amp. The current is practically 0. I should be able to stick that wire down this hole before I fit the capacitor. I think that's probably the best way to do this. Yeah, you can see that goes there into that bit. Okay, so we'll put a very thin piece of wire from pin 3. And we'll leave it long enough to stick down there. Okay, so there's our wire tags on pin 3. This will go to this capacitor. We can deal with the other end later, but now we can start putting these resistors back in and not have to worry about the track that went under this way. The first one then is this resistor, which goes from here to here. I think this one is actually R16. We can have a look on the picture of the good one. This resistor is R16. Yellow, I'm sure this will be yellow, violet, red because that is a standard value. We can also check on the schematic for R16. I'm sure that's what it is though. And yes, we can see that R16 is a 4.7K. So let's fit this one now. There is our 4K7 resistor, and now we can just check with the schematic that we have continuity to the places it should connect to. To make this a bit easier, I've actually just printed out the schematic, or at least this page of it. So R16, we can see that one end goes to pin 1 of the LM393, so that's going to be fairly easy to just check that one. We can check it goes also to R17, to R15, so we can just check all these connections are there. So let's check that on our board. We have then one end of the resistor, I'm not sure which end yet, goes to pin 1 on this chip. Yeah, this end goes to pin 1. It also goes to one end of R15. Yep, there, so we have continuity on that one. It goes to one end of R17. Yep, so we have connection to there. So that, from what I can see, appears to be wired incorrectly. The other end goes to 17 volts, which we could actually find on the voltage regulators, which are further down the board. But 17 volts, according to the schematic, is also one end of R13. And we have that. So that is connected to where it should be on both ends. So I'm happy with that one. Now let's have a look at the other two resistors. These are R18 and R19. We have a 27K and we have a 1K resistor. These are both 1%, so if I have any 1% resistors, I will fit them. If I don't, I will select one manually that is close to the value it should be. On our schematic, we can see R18 and R19 are actually here. They go from plus 17, they join together, and they go to 0 volts, and they go to one of the inverting inputs on the op amp. Okay, let's see if we can figure this out. Well, they're next to R29 and R30. And I think from that I made part 1 as effectively this is 0 volts and 17 volts. Let me have a quick look on the schematic, R29 and R30. I'll do it on screen since I happen to be on the computer at the moment anyway. R29 and R30. Yeah, so 17 goes to R18 to 19. So these two strap across between 0 volts and 17 volts. And the same with R29 and R30. And they're right next to them. So I can solder one end of R18 to one end of R29. And I can solder one end of R19 to one end of R30. And they are actually here. So one can go to there, one can go to there. And then we just need to figure out where the other ends of them go to. I'll solder them on. I've also just noticed, to confirm this is correct, that from one end of here, this is where the resistor went. So that's where one of them goes. And we actually have a connection, and the other one goes here. So because we're just on the edge of this burnt patch, and in ohms range we don't see any resistance, I'm going to actually solder this one in. I think I can probably solder that one in as well. So let's try and clean the holes. I'll try from this side first, but I'll probably end up on the other side of the board. One is here. Other one is there. Okay, that one's clean. That one I'm not sure. Let's turn this over. I can see this one now, so we'll try it from this side. I think that's actually gone, that pad, so this one I think I'll just solder to the end of this resistor actually. The other one I'll put through. Okay, there we have the two. One is actually through the hole which goes to there anyway. The other one is just tagged on the end of the resistor. Again, I didn't have any 1%. I actually have to buy some, but these were close enough, okay? Or extremely close enough, like 1.1% out. This one, we'll just check. Actually, yes, we do have a good connection. And the other one, we have a good connection. So let's see where the other ends of these goes to. Well, in actual fact, we know the other ends actually just connect to each other. And then they go to point A. And point A is one end of R33. I don't see point A anywhere else on the schematic, so if we find R33, we can connect to there with the two ends of these just connected to each other. Okay, let's have a look. Well, of course, R33 is close by, as you would expect it to be. We just need to figure out which end of that we want, and then we can connect these two together and run a wire to it. So one end of R33 I think is going to C22. I don't think that's the end we want. In fact, yes, I can see. No, it doesn't actually go there. It actually goes to the chip. Let's have a look on the schematic. Yeah, that makes sense. This end of R33 actually also goes to this chip as well. So if we trace that through to there, actually we may be able to just tag our two resistors on here if it's closer. Let's see where that actually goes. So we have R33 going somewhere onto this chip. Yeah, it goes onto pin 2 of the chip. That would be a non-inverting input. So we can actually either tag our wire onto R33 or onto the chip directly. It doesn't really make any difference. I'll just do whichever one's the easiest. Okay, it turned out the chip was the easiest place, I thought, so that is soldered onto the chip. Our two resistors go into where they should do. We can actually just check that. So I'll just want to ohms range. We have effectively connection to here. Yeah, that's good. And we know the other end is soldered, okay. So that's those done. The only thing left then really is these two capacitors, 1, 2. I removed these because they actually burnt, particularly this one burnt and one there. So we have 3 capacitors to put back on and just make sure they are connecting to where they should do. The worst one is probably this one. So let's do this one first. This is C20. The schematic will help again. So one end goes to one end of R20 and the other end goes to the negative end, in fact, of C37 and this resistor. So we can check this out. I will actually, I think, just measure from the pads to see if they connect into where I would expect, and if they are, then I can fit that capacitor. So here is C37. This one's not so charred. That's probably okay. We'll go negative end of here. Should go to the negative end of this one. We'll put the bleeper on. So that end connects okay to where you would expect it to go. There's also R36 connecting to here. If we can just see it, I think it's that one. So again, from this one to here, yep, so that's good. And then the positive end goes to one of the pins on the op amp. In fact, it's the same one that the yellow wire is on. Yeah, so that's okay. So we can put that capacitor in. The capacitor is a 33 microfarad, 35 volts. I didn't have any in the right physical size. I have some 33 microfarad, 50 volts. These are pulls, so I've just tested this with a capacitance meter. It's okay. We know which end is a negative, that's fine. I'm just guessing to the board. Yeah, that's fine. And then I'll just do the same with the other 2 capacitors, make sure that the continuity is there that I require, and hopefully that's all this put back together. I've replaced all the capacitors apart from C19. Now C19 is a 10 microfarad 63 volt capacitor. But if we look here, it's actually connected to the inverting input on the LM393. And the LM393 is actually being powered from the 17 volts. I don't see how a high voltage could ever appear here. This is 0 volts on the other end of the capacitor. We have a resistor, 33k and 10k here. This is just a test point, nothing connected. On the positive end, that's coming from plus 17. But we also have this here, temp plus L. Now, if you look at the schematic, temp plus L is actually here. So this is a NPN transistor going to ground. So effectively, this transistor can switch this point to ground, but again, it can't put a high voltage on there. That is supplied by this resistor network from 17 volts. So I honestly don't see how that can ever get 63 volts on it. And this is relevant because I don't have any. I have some 50 volt ones. Pulls again, I'll just test first. So I'm going to put the 50 volts in there. I just don't honestly see how it could ever exceed that voltage. The only thing we need to fix now is this connection. Okay, so this is pin 3 on IC2 and it goes to pin 2 on the LM393. It also goes to one end of C19. This is the track we knew that was broken. I've already tagged a wire on here, and I was actually going to solder this to one end of this capacitor. It's obviously not connected there at the moment, C19. C19 does go to pin 2 on here. So I can actually tag the wire on either pin 2 or on here. I think I'll actually tag it onto the chip again because that worked well with the other ones I did. So I just need to bring this yellow wire to pin 2 on this one. And then there's one more track on the rear to repair. A little bit of flux on there. Okay. We'll just bend this over into position. Bit awkward for you guys to see, but I think I can solder it. Okay. Yeah, that's nicely on there. Pin 3. Just make sure there's no shorts here. Don't think there is. It's okay. Pin 3. Pin 2. Capacitor, which is here. Yeah, and that's that done. That side's now rebuilt. I think that's fairly tidy actually. And then there's just a few tracks on the back we need to check. I think there's one from here to here. We can see it on the picture if we have a look, but I'll just check. Here to... Yeah, we have one there. Just make sure this isn't shorting across here. No, it's okay. Let's just clean that out a little bit. Okay, better. No short there. Then there's just this one that was missing across here. That's this one, so we'll put this one in. And on our board, that actually goes from here to here. I'm going to use a stiff piece of wire here with a piece of heat shrink on it. I think that's the easiest way. And there we have it. I'm quite happy with the way that turned out actually. It looks good to me. We've repaired the various damage that we can find. This side also looks, well, if not exactly neat, it looks complete now. Everything's back on there. I think considering the damage we have, that is a pretty good job, to be honest. These fuses, although they look blackened, are actually okay. I tested them on part 1. That is just smoke, basically, that caused them to go dark like that. So the next thing we can do with this really now, I think, is to put it all back together, and we will have to test it. I will use a current limiter just in case anything nasty wants to happen. Hopefully that will save any more damage if it does, but also hopefully this will actually work now. Before we test the amplified mixer, let's take a look at a product from the video sponsor, Solder Stick. Solder Stick make a range of products, including these. These are for joining together wires. So if you have something like a damaged or burnt wiring harness, you may need a way to repair that quickly in the field. These connectors come in this handy box, the range of sizes as you can see, and they can quickly create a watertight seal between two wires, either on the bench or in the field. The solder stick connector is a flexible plastic sleeve that has 3 bands inside it. The center one is the solder. This is a special low melting point solder, and then the other 2 bands are glue. To use the connector, we don't need to prepare the wires, we just need to strip the ends. We don't need to add any solder or flux. We just simply insert the wires into the connector, like so. And then we can heat this with hot air, or if we're out in the field, we don't have access to hot air, we can just use a cigarette lighter or a similar source of heat. To use this, simply we just heat the solder band in the center first, and this will melt. There we can see it's going, and that tins the wires. Now we just need to melt the glue, so we just heat up one end so the glue shrinks onto the wire, and the same with the other end. Not only does the glue hold the wires firmly in place once it's solidified, it also produces a waterproof seal. Simply wait for the connector to cool down. And now we have a waterproof seal between the 2 wires. This is strong, you can pull on it. I put quite a lot of strain on that, it's not going to break. And this is much easier than using, for example, solder and heat shrink sleeving, especially on site. For example, automotive repair and similar jobs, where literally you just need the box of solder stick connectors and a cigarette lighter. The solder stick connectors come in a handy pack of 500. They cost around $25 per pack, so that's around 5 cents per connector, which is very economical. Right now, if you look in the video description, you will find a discount code you can use with solder stick, which will save you 20%, so that makes them even cheaper. I can really recommend these guys. Buy a pack of these, and I think they will probably last you a long time, and you'll find they're extremely handy. Yeah, keep a few in the car for certain. Well guys, it's all back together again. I think we'll try and lift the top up so we can see inside this. If anything dramatic happens, I'm sure you guys don't want to miss it. So let's just see if we can just get it to balance. Okay, I think that will do. I'm going to switch the current limiter on. So what we want to happen is for this bulb just to come on once and then go dim. So I think now we are basically ready to go. Let's see what it does. Well, it's come on, it's going dim. That's quite a good sign, nothing's gone bang. Let's see if this is powering up. I'll just leave the current limiter on again for one moment. Let's see again. Yeah, there's some lights on, so that's a good sign. Right, let's switch it on then. Whoa. Well, a lot of lights flashed and went out, but that might be okay. And it's on. We need to connect some audio then, some speakers, and let's see if this is working. I hear the fan spin up and then go off again, which I think is normal. Yeah, that looks good. That's both channels working. Yeah. Okay, so this is a good one, I think, guys. And now a bit of Northern Soul, of course, yeah. So yeah, this is obviously working. I'm going to give this back to the guy. let him see what he thinks, and then hopefully we won't see this one again. Okay, yeah. Yeah, I'm happy with that, guys. I heard the fans spin up and then they spun down, so he obviously has control over the fan. That's very good. I can't try this in the office at any appreciable volume. To be quite honest, I only have small speakers and the cafe next door wouldn't really appreciate it. But I'm more than happy to give this back to the guy. I'm confident he can try it, and I'm pretty sure this is going to work. Okay, so I hope you enjoyed that part 2. You've seen some PCB repair there. Get into the comments below. There's possibly better ways. That's the way I did it, and it did work. And I look forward to seeing you all on another Learning Electronics Repair video. Ciao for now, guys.